Hello all, today in this video we are going to make a continuation of the previous video only. The previous video we would have worked with RNN, LSTM, and in this work we are going to work with BiLSTM. With the previous video we concluded that when compared to RNN, this LSTM is providing better results. In this video we are going to see whether BiLSTM is going to provide better results than LSTM or not. So for that initially we are importing the library such as we have done previously, and then the dataset which we have used here is the email phishing detection dataset which we have downloaded from Kaggle. You can just give Kaggle dataset. It will that is email phishing detection Kaggle dataset. In that case, you can get this dataset downloaded. Then we are just checking this dataset is having nearly 3 columns like unnamed, email text, and email type. So within this, we are just checking whether the data set is having any missing values. Since it is having some missing values, we are using the filna function. Then we are using determining the x variable and y variable. Here the x variable is termed as text and y variable is termed as table. Within the text, we are calling the email text column, and within the labels we are calling the email type column. Then we are pre-processing this data with the labels column by using the label encoder function. And then this is just an optional one because email type is the labels which we are going to display. It is a binary classification work only, since it is having two classes like safe email and phishing email. We are making a plot like which plot is having more values. So from this plot, you can conclude that safe email is having some better counts when compared to this phishing email. Then we are determining variables like xtrain, xtest, ytrain, and ytest. For that, we are making use of the train test split function and also the text variables, text and labels variables. And here we have given the test size as 0.2, that is 20% will be taken for testing and remaining 80% will be taken for training. And we have determining the random state as 42. Again we are making some tokenizer to convert this xtrain and xtest to tokens and also padding it, that to check whether it is having some uniform length. For that we are using the tokenizer function and also the pad sequences. This padding values only we will be used in the every models like RNN, LSTM, and BiLSTM. So with RNN we have worked with some 4 different differentiations, and also we have made the comparisons which one is providing better results. So for that you can just check with our previous videos. So this is the layer contribution of the RNN. So first it is having the sequential layer, embedding layer, simple RNN layer, dropout layer, dense layer, then optimizer. Here we have given the Adam optimizer, and also we have specified a learning rate as 0.001. So now for other models also it will be like in the place of simple RNN it will be replaced by LSTM for LSTM architecture, and by bidirectional LSTM in the case of bidirectional LSTM. So all others will be same only. And with this simple LSTM, simple RNN, we have worked with changing the dropout rate and without using dropout rate, and with changing the learning rate and all we have worked. You can just see, and there is some differences also. While working with without using it and with using it, there is some difference. So in order to check this, you can just check our previous video. So we have worked with this differentiation in the previous video itself. So only in this video we are not including it. So LSTM also we have worked with previous video. As I said previously, in the place of simple RNN, it will be replaced by LSTM and all others are same only. But when compared to this RNN, LSTM will providing better results. That is validation accuracy is having nearly 9499. Then we are working with BiLSTM. With this BiLSTM, it is also same as LSTM only, but in place of LSTM we are again adding and bidirectional to prove that it is a bidirectional one. All others are same only. Here you may notice the validation accuracy is 9499, but here we have some improvements, that is 9651. So you may notice that with bidirectional LSTM, apart from this LSTM, it is having some improvements. So this improvements we have plotted in a graph. Here you may notice. So here the graph itself is showing that this bidirectional LSTM is providing better results when compared to this RNN and also this LSTM. The same takes place in loss also. So this is the code for email spam detection algorithm with deep learning algorithms. In this next video, we will be working with some other deep learning algorithm. Thank you.